67. 67 says calculate the force acting on an electron of charge 1.5 times 10 raised to the power minus 19, placed in an electric field intensity of 10 raised to the power 5. So I'm looking for force. So force is equal to QE. That is charge times the electric field intensity. So you're going to put 1.5 times 10 raised to the power minus 19 times 10 raised to the power minus 5. Sorry, 10 raised to the power 5. That's not 10 raised to the power minus 5. All right. So that way you're solving. This QE, that is that. All right. So 70. 70 says what charge is stored in a 0.1 F capacitor when a 10 volt supply is connected across it? Straight forward. Straight forward. All right. What we're doing here is Q, which is charge. Q is charge. So we're going to say capacitance times volt, or capacitor times volt. That's so what you're solving in essence is 0.1 times 10. So you're solving. If you solve this, you should get your answer. It's very straightforward. Yeah, the answer is even there already. 0.1 times 10. That's what you're solving for 70. 72. 72 is saying same thing. It said the plate of 0.5 microfarad on charged capacitor connected to a 10 volt battery. The charge on the capacitor after a long time is what? So we're looking for the charge on the capacitor. No time was given, just charge on the capacitor. So we're going to say charge is equals to what? C times V. But this time our V is 10. Yes, our V is 10 is equals to 10. Yes, no problem. Our C now will be what? 0.5 times 10 raised to power minus 6 because of the microfarad. So what you'll be having will be what? 0.5. So what you'll be having is 0.5 times 10 raised to power minus 6 times 10. This is what you are solving to get your charge. That is what you are solving to get your charge. All right. So I think the next one is just here. That's 75. So let's just scroll down to there. All right. So that's 75. All right. 75. 75. 75 says if the voltage applied across a plate of parallel plates capacitor is separated by a distance of 0.02 m is 5 volt, the magnitude of the electric field intensity is what? All this English you are speaking, we are still looking for E, the magnitude of the electric field intensity. So we are still looking for field intensity, electric field intensity. That's what we are looking for. So this will be what? Equals to voltage over distance. Voltage over distance. What's the voltage? The voltage is 5 and the distance is 0.02. I am giving you almost everything to solve. So that is how you solve that. Voltage over distance. Alright. Then I think the final one for this chapter we're solving is 76. 76 says if a charge of 2 micro C is situated in a field intensity of 400 Nc minus 1, the force on the charge is what? So what we're looking for here is force. And force has always been what? Force is equals to what? QE, charge, multiplied by the electric intensity. And remember, always remember that anytime we have a micro in front of anything, we are equating it to what? 10 minus 6. So what we are solving here is 2 times 10 raised to the power minus 6 times what? times 400 is what you're solving. All right. Thank you very much.